But you can really finish when you really want to. Yeah, that's not
Okay, I think we stop off at number 7. Is that right? We did number 6, but not number 7 yet. On page 3. Okay. So okay, so here's number 7. It looks like the same graph, but now we're looking at it from the fact that this is the derivative graph. It says that f is the derivative of g, and we're trying to find what could be a graph of g. So this is g prime. So keep in mind now this no longer is the original graph of g, because the y-axis now represents the slope value of the g graph. So I'd like to start off by labeling what I'm working with. So I know that I see 2 x-intercepts here. I'm going to call them C and D. Place them on a sign line to help me see how the actual graph could be looking like. So I know that to the left of C, the graph is going to be decreasing. Between C and D, my graph is going to be increasing. It's be above the x-axis. And to the right of D is going to be below the x-axis, so decreasing. So I'm expecting relative min at C and relative max at D. And then we know that we can also gather information about the concavity of the graph, looking at the peaks and valleys. So we do see a point of inflection at this point here. I'm going to call it point E. To the left, my graph is, this is a positive slope. Positive slope of the derivative graph is going to correspond to concave up and then concave down. So I just want to just create my own version of the graph before I look at my options here. So I know that at C, I'm going to have some relative minimum. I'm going to just pick a arbitrary point that is below the x-axis. And then point D, I'm going to just arbitrarily choose a point that's above the x-axis. And then I know my graph is going to be relative min followed by relative max. I know there's a point of inflection at E, so I'm going to just choose E as some point here and concave up followed by concave down. And my graph may be a little bit off-centered, but at least I can kind of get that shape. And that shape is all I need for me to match with answer choice B.
Like showing work. What if I just do process elimination?
That's fine. That's fine. Yeah, I just wanted to give you a process of working through it. If you have a more efficient way, then yeah, this doesn't require any work. Okay. As long as it makes sense in your head, that's good enough. You don't have to show any work. Okay, try number 8. Remember, this is the derivative graph. You're already sitting at the G prime for you to gather your slope sign line information. So okay, try number 8. Give you guys a chance to try it, and then I'll go over with you.
free, and like I don't know the y value, I just the x value.
That's right, that's right. That's all I can, that's all I can provide, just the X value, because there's no other way of getting to the Y value.
You don't find the extreme for points that are outside the domain, right? Or it says x greater.
Oh, that's right, greater than 0. You're right. So
Yeah.
I don't even have to consider that one. You're right.
So how do you know that the vertical asymptote 0?
Yeah, this is kind of just like an educated guess that the function before it had an x, and when you find the derivative, that denominator is going to show up again. So it's just typically if there's a denominator with no radicals, this is indicating that that vertical asymptote came down from the original function, and it'll continue to be there. Quotient, yeah, will continue to be there. But yeah, I think they took that, they made that condition there, so you don't have to worry about what's happening at 0. Okay, for number 9, find the interval where the graph is concave up and decreasing. So make your slope sine line, make your concavity sine line, and then line up both your sine lines, and then it's easiest to just kind of look to see where you're seeing those two behaviors pop up in the same interval.
It's kind of hard to like keep track of different points, see like same time after all the sign lines.
Um. Well, I think if you line everything up, it makes it a little bit easier, though. So you know that -3/3, it's in that -0.5 negative 1.5 range, kind of.
Yeah.
So, but if I try to line everything up as best as I can, concave up and decreasing, so concave up is only here, right? So it's gotta be in this region. So this doesn't work, so it's just gotta be in this little region here. It's the only room I'm gonna have both those properties show up at the same time.
Oh,
So I think if you line it up, it's not too bad, but, yeah, otherwise I think it'll be harder to know when both those things occur. Okay, number 10, try the optimization problem.
Your page of 1%.
Or number 8, yeah. Yeah, technically I've not say anything about 0 since, I forgot that. Missed the fact that, the restriction is for positive numbers. Pi's fine, yeah. Thank you. Okay, if you're using different variables than me, it'll all work out at the end. Our dimensions will still match. So number 10 is where we create two equations. One is area, the other is perimeter related. But perimeter and cost, they kind of go hand in hand. So we can put the cost portion into my perimeter equation. And ultimately, I'm trying to optimize cost, so I know that's ultimately the equation I'm trying to work with. I'm trying to get that down to one variable on the right side. So the area is that supporting equation that's going to help me replace one of the variables. And once I get my cost equation down to one variable, I can get it ready for power wall, take the derivative, set equal to 0, solve for x. That is my optimal.
That's know which side to like make it, like make the gate. Like, how do you know which side?
It doesn't matter. Yeah.
Oh,
I
I
mean,
have a different answer because
yeah, let me look at yours. Awesome. What was your equation? It's possible 40y plus 20x,
yes,
and you solve for x
I solve for y.
off of y.
Yeah. I think the side actually matters, like the entrance. It's
I think this is the same thing as your square root of 2000.
Yeah, the square root of 5 and the one that's confusing me.
So once you have your square root of 2000, plug in to your area to find your other variable. It just means that our variable got swapped, but we should have the same.
Oh.
Yeah.
The dimensions are gonna be the same.
Exactly. Dimension is the same. That's what I'm looking for. Yeah. Any questions here? Okay, so this one also costs, but now we are associating volume with surface area, and surface area is what goes hand in hand with costs, right? Because the material that costs money is not the space inside the box, it's the material that makes up the box. So the volume is gonna provide as, it's gonna act as the assisting, the supporting equation for our cost equation. So I just started off by building my surface area equation, and then I worked in the cost once I have my surface equation. So my base is 4y, and then my front facing vertical side is xy. There's also a back one that's xy, and then the smaller, the sides, vertical sides are, it's 4x. And then this base has a $10 associated with it, and then the vertical sides is $5 associated with it. Multiply that through, replace all the y's from the volume equation that I found. And then just use power rule, get a regular power rule derivative and solve for x. Okay, everybody good with 11?
If I want to see if that prime axis decrease, I just check the concavity. Or
Oh, hold on. Say it again.
So if I want to see, see if F prime is increasing, do I just look at the concavity for?
Exactly, right. Yeah, F prime is negative, so negative slope and concave. Yeah. So the reason why this doesn't quite meet that standard, that looks more like a point of inflection. That's not a clear cut concave down, looks like that's changed from concave down to concave up. This is more clear cut. This is obviously all concave down, so that's a better fit.
We can see number 14 answer.
Mhm. 14A.
Okay.
And remember, when you're finding critical points, from either f prime or f double prime, that you're considering both the numerator and the denominator, right? Right, let me know if there's a particular problem you want me to go over in detail with you. Okay, so the test will reflect the topics that you see on this. Test will be 4 pages long, not as long as this, but it'll have one of each type of problems that you see here. So one optimization, one derivative graph where you have to gather all the information about curve sketching, and you get to use your calculator. Help session, I'll have help session Friday morning, 7:15. And tomorrow we'll start a new unit, but gives you an extra day on your own to study and review.
Is there a problem where where you just give us a function, we have to find all the information and graph it, or?
No, the closest one I'll give you is the f prime. I'll give you f prime graph, and then you'll list out information. You'll sketch me f of x and sketch me f double prime. Yeah.
Okay.
All right, can get your phones.
That's